I'm Dr. Elisa Garcia-Wilson, and I'm the Sustainability Officer for the School of Life Sciences in the University of Dundee. So I'm going to tell you a little bit today about what I do, what my role is, and particularly about, as Patrick hinted, a project that I completed last year looking at the footprint of our institute. So this job came around from the University of Dundee, Cambridge and Edinburgh, getting together and applying for a grant from the MRC for the MRC units that are embedded in these life sciences to have basically a climate crisis grant where we could see what our emissions were, get actual data, and then try and improve sustainability. So just for clarification, the MRC is the Medical Research Council in the UK. It provides funding for individuals. It also has standalone institutes like the Francis Crick based in London or the LMB in Cambridge. But as well as those institutes, it funds multi-lab units that are embedded within life science research in universities. So I didn't know how to do a carbon footprint when I started, and none of us scientists knew how to do it. So we worked with an energy consultant, they specialise in design. This was put out to tender, and the people that won the tender were called Sweco. So Sweco were going to do a full and thorough carbon footprint on the units in Edinburgh, in Dundee and in Cambridge. Well, we got a spreadsheet through from Sweco where they asked us for an awful lot of information. It was called an RFI, or request for information. And there was a bit of back and forward about which categories were relevant, because they gave us they'd never worked with a university or a research lab before. So there was a bit about back and forward about what was suitable, what was appropriate for our situation. And these are the categories that we came up with. Now, when you do a carbon footprint, there are three different scopes. You have scope 1, which are your direct emissions. And like, for instance, anything that you use directly on the campus or on the premises. So if you think about in a laboratory, it might be your Bunsen burner. That's a definite scope 1 emission. There's also scope 2, which is your indirect emissions. So you use a lot of electricity. It's made somewhere else, but it's made somewhere else for you to use it on site. So those are your scope 2 emissions. And then there's scope 3. Now, scope 3 is a bit of a knobbly one. If you were here couple of weeks ago, you'll have seen Patrick do a little half-hour session on scope 3 emissions and how to measure those, and so you'll know that they're a bit tricky. But that's basically all of your other indirect emissions that are upstream and downstream of your institute, and that does include, you know, your business travel and the commuting and everything that you buy, because you're responsible for the emissions in making those things. So if we buy TC plates from, say, China, we're responsible for them being made in China, shipped over, and so we have to take responsibility for those emissions. For things like commuting, that was a little bit interesting. So we decided that we would give, so for, you know, if you're doing a personal footprint, it's how you get to work. But we decided to include the fact that we have undergraduate students coming from abroad. They're only coming here because they're coming for their degree. So we allocated an international flight for each undergraduate student, depending on their home country, to try and make it, you know, the most accurate footprint that we could. We felt that was important. And I think for universities in particular, I don't know how it is in other countries, but the UK funding model, and particularly in Scotland, Scottish students don't pay fees, and so we're quite reliant on international students, and it's wonderful to have an international campus, and you know, that's great. You get the best minds from all over the world, but it does mean that there are a lot more emissions associated with people flying from, you know, East Asia or you know, wherever, North America, to come here. There are a few caveats before I give you the hard data. When we were doing this, we realised the quality and availability of the data was different. It was different between each site. There were a lot of estimates that we had to go on. Our unit, we ended up making an estimation as a proportion of the Life Science Institute because we couldn't dissociate ourselves from the rest of the building. And a good example of that is the waste output. So the company just picks up waste from all around campus, and it didn't have a breakdown even by building by building. So I went down one week and weighed every bag of rubbish that left our institute. That was a fun week. That smelled bad. It wasn't great. And, divided up into the different categories that I wanted, what was getting recycled, what was going to landfill, what was clinical waste. So I took fairly accurate measurements, but for our one building, I couldn't break it down into which researchers. So I couldn't say that this was from the MRC unit within life sciences. So then we had to just allocate a proportion. And that wasn't a problem that the other locations had. So we each had different areas where we had to maybe make estimations that the other institutes didn't have to make. And then there are conversion factors. It depends which conversion factors we used. I mean, we used industry standards, but I think a lot of these will get better in the future. At the moment, they're estimated, for instance, your purchasing is estimated on your spend, and there are a lot of caveats with that, as you all know. So this is the footprint, first of all, for Dundee, which is where I'm based. And you can see the two big chunks that jump out at you are, first of all, our fuel, and second of all, our purchased goods and services. And so I guess, if I'd said to you, what do you think the two biggest issues in a laboratory are? The energy and all of the consumables that we buy. It's not a surprise, really, that these are our two big chunks. And you can see that for Dundee, we have this huge chunk of natural gas. Now, that is a problem that a lot of universities, probably most universities in the UK have, that we all have these power plants ours is based on campus. It pipes in natural gas and converts that to electricity and our heating. Financially, that makes great sense. But obviously, climate-wise, it's not great to be relying on gas for your power. And this is one of the first obstacles that we come up against being embedded in a university. That's not something that we have any control over. So obviously, if I got this footprint as, personally, or if I have a small company, I commission this footprint, and then we look at the hotspots. The first thing I'm going to do if I'm really serious about getting to net zero is turn off that gas, switch to renewables. But that's not an option that we have. And so then we have to look at the rest of the pie. We can still lobby the university and make very clear what we want, but it's not something that's in our power to change straight away. So yeah, we're going to have to look at the rest of the pie, and that is going to be a lot of behaviour change, which is hard. People changing what they buy, which can involve maybe being slightly more expensive, people reducing and reusing, which is, habits have to change, and they have to look at their protocols a bit more. So yeah, there's a lot, but it's not going to be that big, easy chunk where you're going to identify and say, oh, that's all we need to do. We can get to net zero. It's actually going to be a lot trickier. So that's Dundee. How did that compare? Are we really strange? Are we very different? Or is it a very typical laboratory footprint? Well, it turns out that the numbers are actually fairly similar, except for Cambridge. And Cambridge is an interesting one. We'll come back to them. But Dundee's total footprint came up at about 3.5 tonnes, very similar to Edinburgh. Cambridge is a bit smaller, so it's about 2/3. And I hope you can see that's because our energy profiles are really different. The reason the energy profiles are different is because Cambridge is already away from gas and it's on the grid. They're only using grid electricity. Now, they're in England, so they don't get as much of a proportion of renewables as you would get if you're in Scotland. Scotland has got a phenomenal amount of renewable electricity. In fact, we have so much renewable electricity that sometimes the grid asks the wind farms to stop because the infrastructure, the power cables aren't capable of bringing all the electricity onto land. So some things are not joined up in the UK, and our grid system is one of them. That's something that we really have to look at, especially if we're serious about getting to net zero. But the power is there, the renewables are there, and we just need to link things up a bit better. So you can see Edinburgh's got a different profile again. They've got more of a mixture of natural gas and electricity. And again, just to make it the comparison a little bit easier, if we put absolute values for purchased goods and services there, you can see that Cambridge aren't spending very much more than Edinburgh, but their total tonnage overall was about a third more. And that's simply down to the amount of power that they're using, or the carbon footprint of their power. So that's what I would love to see happen, for Dundee, would be that switch off and our footprint to shrink immediately, by 30 to 40%, simply because we're not using natural gas anymore. If we look at how much the values for energy are, in Edinburgh, you've got about 2 tonnes. Dundee, it's a bit less. Cambridge is it's really winning. And that's adding up the percentages for natural gas, or the values for gas, for electricity, and fuel and energy related. So that's this pink section on the graph. Fuel and energy related, that comes under scope 3, but that's all related to getting, say, the gas out of the ground. So those are called well to pump emissions. And obviously, if you've got renewables, your FER shrinks again. So yeah, that's where those differences come in there. And you can see that it makes a difference to the totals with Edinburgh and Dundee, even though they've got different energy profiles. They've got quite similar amounts of total footprint. And Cambridge, it really is down to their much lower energy profile. So the purchase goods and services, that's where we're left, is one area of where we can really improve, and that's an area that the university has really decided to focus on, and that's going to be the university's net zero strategy for the next few years, is focusing on this purchased goods and services and the scope 3 emissions. I hope, although I'm not privy to this, that in the background our CHP plant is coming to an end of its life, and that the future direction that the university is deciding to take is going to be towards renewables. I honestly can't think that they will do anything else. I don't have a timeline for that, but obviously I'm hoping that it's sooner rather than later. So what do we do now that we have some hard data, now that we know, we've identified hotspots? Cambridge, for instance, are going to put themselves onto a renewable tariff so that they can reduce their energy footprint even further. And then what can we do? What are our goals going to be? This comes back to what my job is now, my everyday job in the Institute. So my hope, obviously, is to try and get my institute towards net zero. A big part of that is LEAF. So that's the Laboratory Efficiency Assessment Framework, and that's something that we're trying to establish, that hopefully every lab in the building will sign up to this. If you don't know LEAF, you maybe know My Green Lab or some other equivalent, Green Impact. And it doesn't really matter. I think what it makes sense is that there's a easy framework for people to see a list, be able to think, oh, okay, that's where we start, and get going with making sure you've got recycling bins, making sure that your temperatures are optimized, and making sure that you don't have lots of extra unnecessary samples in cold storage. A list that you can just think, okay, this is us being the most efficient. And with efficiency comes sustainability hand in hand most of the time. I also do public engagement, and I include other scientists in that because I have to do a lot of scientific engagement, persuading people that they want to be part of the green team, they want to be part of this movement, they don't want disposable cups, they want to have their own mug, big and small things. And yeah, so I spend a lot of time doing that. And we also try and find interesting ways to get rid of some of our waste. So we collaborate with our art department, our School of Art. They have a reuse hub, and they really enjoy getting weird and wonderful scientific, don't want to call it junk, but stuff that none of us want. If you've ever wondered what to do with out-of-date TC plates that no scientist is going to want to put their cells into, the artists will take them. And they come up with amazing things. They really enjoy getting our junk. So that's one way we can give. Usually I will give them things that can't be recycled, because I don't see any point in giving recyclable things that they can then fuse together and create something that's unrecyclable. So something that can't be recycled can get another life at the School of Art before it ends up wherever it's going to end up. I've also tried to embed sustainability and sustainable thinking into our undergraduate syllabus. So last year I gave the first years their first sort of sustainability framework for their careers in research, and getting started on their undergraduate degree. This year I'm going to go back, do the same for first year, but also take it up another level for second years. And we've tried to embed more and more sustainability inductions at different levels of the institute, so that everyone, and make resources as well so that people can refer to things, but also make sure that everybody can have access to a sustainability framework for how are we doing our research, how can we improve, and how can we change things for the better. And of course, it's easy to identify problems, but sometimes it's not so easy to identify solutions. But I get asked sometimes to go and do a walkthrough of a unit or an area, and then we talk about what do we think we could do better. So this morning I was at our animal resource unit, which, as you know, uses a lot of energy. And so we're going to put our thinking hats on now and see how can we reduce energy and how can we improve with PPE, which is absolutely necessary, but of course mounts up. And so we're going to try and think of solutions to make each part of the building and of our research institute more sustainable. And that was my quick fly through carbon footprinting and trying to make our labs more sustainable. And I have a long list of thank yous, lots of people who helped me gather all of the data for the carbon footprinting. And thanks to Patrick for inviting me along. And also the MRC and the University of Dundee for my funding and my position. A brilliant question. And the sad answer is no. So before I began this process, and SWECO gave me the list of things that they wanted, and they asked for suppliers and how much we'd spent with each supplier. And I naively thought that's because they would go and find out the carbon footprint of each type of goods or what we were, spending a lot on. I thought we would get that kind of granularity. But in fact, the tools for that just don't exist. And I think that in the future, because there is a lot of demand to know this, the tools will improve. But in fact, at the moment, what you give is a spend, and the carbon footprint is calculated from spend. And the theory or the logic behind that is along the lines of if you spend more, you've used more stuff. However, the caveat there, the fall down there, is that sometimes to buy a more sustainable option, so some of you might have heard of Eppendorf's bio-based line, where they make PP, polypropylene goods like pipette tips or Eppendorf tubes, actual Eppendorf tubes from Eppendorf, and they make them out of used oil. It's a bio-waste, like not fossil fuel oil, but cooking oil. Those are more expensive. So if we put them into the mix, we come back with a bigger carbon footprint with the tools that we have at the moment because we spent more. But in fact, we used a better product, a more environmentally friendly product. So that level of granularity just isn't there. But I think if I were to do the carbon footprint again with everything that I learned, I think that there is potential for specialist footprinting into this area, and the tools will come in the end. Life cycle analysis are going to be on the cards, I think, in the future. What we're going to try, this is what I'm speaking to our suppliers at the moment, saying that I would like to see this kind of analysis so that you can choose between one product and another. But that's a big ask for them at the moment because nobody has really asked for that before. And so they're trying to catch up with what we're asking from them now.
I think what you just mentioned is a big problem after all, that no matter what you look at, I once got the question, what is, more sustainable? Should I buy a new freezer that is more energy efficient, or should I basically keep the one I have right now? And obviously it depends, right? I mean, how old your freezer is, how much it needs. But if you then look into the analyses in the literature, you can do things like the life cycle analysis, but there are also other quote unquote approaches that are to some extent similar and different, which is, for example, material flow analysis, where you look at, where do the materials come from and where do they go? And I think, Elisa, you mentioned it as well in the beginning, right? It is a lot of assumptions that go into this. I mean, you need to assume how often basically, your supplier is shipping something, let's say from Asia to Europe, and how long it takes these ships to get there. And then, from the haven, is it then transported by truck? Is it transported by train? And so on and so forth. So I think this is a common problem that we encounter. And I think the most feasible things for most of us to do is to just stick to the things that we can estimate ourselves. So the rules of thumb, so to say, right? So if you have a supplier that is basically on the same continent as you are, this is going to be probably the better choice. If you have somebody, again, like Eppendorf, that actually can prove that, 90% of the polypropylene is from these plant oils, that is probably a better solution. And I think the other thing that everybody can do for their own procurement is just to order less often and with more systems, so to say, right? So if you can gather basically what you order, this will, of course, reduce the frequency. And I think this is something that every lab has to do on its own. It can't just be an Excel list where you collect something. It needs somebody to take care of this, but this at least will help that you make sure that your antibody is always there in time and that you know where they are, because I think it has happened to all of us that you order something and then it somehow ended up somewhere else. And maybe you found it after a year, but obviously this doesn't help for your experiment. How was sustainability again perceived when you started this whole project? How big was the buy-in and how many questions did you get about sustainability in terms of, do you want our footprint? Do you assess other footprints? Is it about ethics? Is it about something else? How was it perceived overall?
Well, this was something that was quite different for us. So it was starting from zero, really. The university, so in Scotland, we have a legislative obligation to return our Scope 1 and Scope 2 emissions, and a voluntary for Scope 3, although that's going to come into being, enforced in the next few years. But universities aren't really required to carry out this kind of analysis. At that time, when we started this, the university hadn't done any kind of analysis on its footprint. And so researchers were really fascinated that we were going to do this, and everyone wanted to know, well, I think we were all scared to find out what the results were going to be. We knew that our institute used, so as I said, we have this power plant that supplies all of campus, 96% of the energy on campus, the electricity and the heat, came from our power plant. And of that electricity, we are reported to use about 45 to 50%, just our building. Now, we don't have 45 to 50% of the footprint of campus or the people. So just by coming into work, every researcher is taking on, again, the same, like doubling our carbon footprint that we have just as individuals outside. I think people who are scientists care about ethics, they care about the planet. We tend to be more interested in the natural world. I think the irony of it all is that we find out that we're having a bigger impact than, I don't know, the lawyers studying law and or the accountants, which isn't, not to say that they're not interested in the natural, but there is this irony that because we're so active in what we do every day, even though we care, we are ending up with this massive footprint. So I'd say people are very engaged, people are very interested. Getting people to give up their time is a little bit more tricky. And Patrick and I have spoken about this before. But yeah, in general, people really wanted to know. And we were scientists, so we wanted to know the data.
Totally feel you there. I've once heard from a colleague, she's more on the medical research side as well. And she said the weird thing is that with whatever we do in terms of research, we contribute to some extent to the illnesses that we cause sometimes, because she was working on, any kind of lung diseases and illnesses. So it is a weird thing. And let me ask you about the experiences and tips that you would give everybody here in the audience to basically, if they would be interested in measuring their own footprint or supporting the sustainability officer, what did you learn that you would like to share with people?
So if you have a sustainability officer, you are a blessed person, and I think you should take them cakes every day. That's what I think you should do to support you. Then you will have a very fat sustainability officer. No, I'm joking. Yeah, I think one of the most valuable things that I've learned trying to set up sustainability in a more structured way, first of all, having the data was great. Finding a way, and you don't have to go through a hugely detailed carbon footprint. If you could find metering, find a way to to look at your energy use. And then once you start implementing savings, if you can find a way to see that go down, set yourself targets. Like, could we, as an institute of people that are maybe 800 in a building, can we reduce our energy footprint 4 or 5% this year? If you've got the low-hanging fruit of, ultra low temperature freezers that are at -80 instead of 70, your fume hoods are open all the time, or these are the easy wins, try and educate people to make some changes there. If you already think, oh, I'm so sustainable, I don't know what to do with myself, look for reducing and reusing opportunities. Go through protocols with people. If you have a sustainability officer, talk to them, tell them what your problems are. And, I can't tell you how delighted I am if somebody comes to me and says, I'd like to be more sustainable in the lab, but I can't quite figure out how. Can you come and help me? I am delighted to do that. I heard of the sustainability officer in the EMBL. She's trying to phase out bought PBS. She wants to have all the PBS in her institute made in-house. Oh, there's a great resistance to this here. And it's true, though, we are transporting, vast quantities of salty liquid that could easily be made in-house. So yeah, if you are going to ask your sustainability officer for help, listen to the suggestions, be willing to try different things, be willing to set aside a little bit of time to experiment on your experiments. And that is difficult because we're all in these highly pressurized jobs. We have to get results to get the next grant, to get the next, position. And it is difficult. Publish. But if you can take a little bit of time to just experiment on your experiments, that would be that's what I would do. And something like a framework like LEAF or My Green Lab, something that gives you a checklist of things you can easily look at, that gives you structure and makes it easier for you rather than sitting thinking, okay, what do I do now?
Thank you so much for having been here, and have a beautiful evening.
Oh, thank you for inviting me, Patrick. It was really fun.
Absolutely. Have a good time.
See you later. Bye-bye.
Bye-bye.